All right, greetings everyone. Welcome to the third part of the video for section 5.3, continuing on with our study of the relationship between circles, angles, and sine and cosine values. So you recall in a previous video, we looked at finding the sine and cosine for pi over 2, which was the same as 90 degrees. Now we're going to look at finding the sine and cosine for pi over 4. And we're going to work again with the unit circle. We'll use our Pythagorean identity in here, and we kind of get to tie a bunch of stuff together. So what I'm going to do, as we've done a lot of problems in this section, I'm going to start by drawing the unit circle. And so call this here, that'll be the unit circle, even though I know that's really terrible. In fact, let me redraw that. Okay, I think that's a bit better. And then we're talking about an angle of pi over 4 radians, which you can convert, or maybe you know, that pi over 4 radians is the same as 45 degrees. So if we, here in a unit circle, add an angle that's pi over 4 radians, it'd be somewhere right about here, about halfway through the first quadrant. And what I'm going to do here in the picture is label the angle. So this is, I call this 45 degrees, pi over 4 radians. And because this is the unit circle, we know the length of our radius here is 1. So the r value equals 1. And we also know that the point where this line intersects the circle, that point xy, well, that's going to be what the cosine of pi over 4, or 45 degrees, and sine of pi over 4 will be. So they will be those x and y values because this is the unit circle. Recall that that does not work if this is not a unit circle. Okay, so what I'm going to do now is I'm going to drop a line down from that point at a right angle. And notice what that does now is create a right triangle in our picture. So this here. And in that right triangle, notice that we already have a 45-degree angle and a 90-degree angle. And because we know that the sum of the interior angles of a triangle is 180 degrees, if we do 180 degrees and take away 45 degrees and take away 90 degrees, what we find is that the measure of that missing angle up there is also 45 degrees. Okay, so what I'm going to do then is kind of zoom in on the triangle picture we have now. So I'm going to take that, kind of pull it out on a larger scale. So our triangle now looks like this. And again, this angle is 45 degrees. This angle is also 45 degrees. The length of this longest side here is 1. And also notice that in this picture, right, the length of the lower side of the triangle, this one here, well, that's going to be the same as the value of x, right? Because that's how much we have to go over from the origin to get to this point. So we know this length here is x. And then the vertical length there, well, that's going to be y, because that's how far we have to go up to get to that point up here, right? So that's going to be y. Now notice also in our triangle that our two angles here are the same, the two 45-degree angles. And you may remember from past math classes or past geometry class that if two angles are the same in a triangle, then their opposite sides also have the same length. So the side opposite this 45-degree angle and the side opposite this 45-degree angle will be the same, which is what those two tick marks show us. So what does that tell us about x and y? Well, right, that tells us that in this case, for an angle of pi over 4 radians, or 45 degrees, x equals y. But also recall that x is the value of the cosine of the angle, and y is the value of the sine of the angle. So here we have that, whoops, not that. We have that the cosine of pi over 4 is going to equal the sine of pi over 4. Okay, so here the cosine and the sine are the same, is the moral of the story there. Now that's not true for every angle, but it is true for pi over 4 radians or 45 degrees. All right, this is where this starts to get fun now. I'm going to go back to our Pythagorean identity. So remember the cosine squared of theta plus sine squared of theta equals 1. And so what we're going to do is, since we're dealing with a 45-degree angle or an angle of pi over 4 radians, we're going to plug that in here. So this will become cosine squared of pi over 4 plus sine squared of pi over 4 equals 1. But then we also know that the cosine of pi over 4 equals the sine of pi over 4. So I'm going to use that then to replace this sine squared of pi over 4 here with cosine of pi over 4. So this would be cosine squared of pi over 4 plus sine squared, or sorry, cosine squared is what that should be. Cosine squared of pi over 4. And again, that's because we're replacing sine with cosine, since up here we know that cosine of pi over 4 equals sine of pi over 4. Okay, so what we can do now then, now that we have that, is combine our two cosine squareds, because we have a cosine squared pi over 4 and a cosine squared pi over 4, so those are like terms. So that would give us 2 times cosine squared pi over 4 equals 1. And hopefully you see at this point that we have our equation now in terms of just cosine, which means we should be able to solve for it, which is where we're going next. So actually actually no, I was going to erase everything, but I'm not going to do that. But I just erased something that I didn't want to erase, but you know, stuff happens. Okay. So we're going to take this and write it over here now. So we've got 2 times cosine squared of pi over 4 equals 1. To solve for cosine, we'll start by dividing both sides by 2. So 2's cancel here. So now we have cosine squared of pi over 4 equals 1/2. To solve for cosine, we need to undo the squared there, which means we can take the square root on both sides. Remember, when we take a square root, we have 2 answers, a plus or minus. The squared and the square root cancel out on the left-hand side, so we have cosine of pi over 4 equals plus or minus square root of 1 over 2. So we're now going to simplify that plus or minus root 1 over 2. Then we'll make this plus or minus square root of 1 over square root of 2. Square root of 1 we know is 1. Square root of 2 we can't do, so we'll leave that as square root of 2. However, you may recall from past mathematical experiences that mathematicians generally do not like having roots in the denominators of fractions. So we need to get rid of that square root of 2 on the bottom. So we can do that by actually multiplying by square root of 2 on both the top and the bottom. This is called rationalizing. Okay, and when we do that, what we'll get, well, on the top we'll have 1 times root 2, so that'll just give us square root of 2. And on the bottom, notice we have root 2 times square root of 2, which when you multiply two things under a root, you can multiply them. So let's give us square root of 4, which notice is just 2. So this becomes plus or minus square root of 2 over 2. Now what all that long work has done now is given us a value for the cosine of pi over 4. So we have the cosine of pi over 4 now is plus or minus root 2 over 2. Now as I discussed at the end of the last video, the cosine value cannot be either plus or minus. It has to be one of those. So how are we going to decide which one it is? Well, going back to over here, recall that the cosine value is equal to the value of x, where our radius was touching our circle. And recall that for an angle of pi over 4, that happened over here in the first quadrant. And let's think about, should the x value there of a point on that circle be positive or negative in the first quadrant? Well, it should be positive, right? So that tells us then that the cosine of pi over 4 will be positive root 2 over 2. Whew, we made it. Wasn't that fun? I thought it was fun. Okay, but we're not done because we still need to find sine of pi over 4. So do you recall how we're going to do that? Or do you think you know how we could do that? Well, recall that this thing I circled up here, we know that for that point I just pointed out, x is equal to y, which the thing I meant not to erase here was that told us that the cosine of pi over 4 was actually equal to the sine of pi over 4. So since we have cosine of pi over 4 is root 2 over 2, we also know that sine of pi over 4 is also root 2 over 2. Okay? And I know I just went over a bunch of long, kind of complicated stuff, but that thing I just boxed in blue, that is the moral of the story here. That is what I want you taking away from this video, or from this process, is that the cosine of pi over 4 is root 2 over 2, and the sine of pi over 4 is also root 2 over 2. It's okay if you can't replicate the process we went through to get there. Okay, now the sine and cosine of pi over 4, or 45 degrees, is something we're going to have to memorize because we're going to use it lots and lots of times throughout this quarter. And there are also a few other sines and cosines that we're going to need to memorize. So this table here, which is from your book, shows what those values are. So first of all, here in the middle you see the ones we just found. So for pi over 4, 45 degrees, the cosine was root 2 over 2, and the sine was also root 2 over 2. We also need to know the cosine and sine for 30 degrees, which is pi over 6 radians, 60 degrees, which is pi over 3 radians. We did pi over 2 in our first video for 90 degrees, the sine and cosine. Also for 0, and that's either degrees or radians, it's the same in both. And then some additional ones you're going to end up memorizing will be for 180 degrees and also 270 degrees. Okay, so again, these are ones you're going to have to commit to memory. They will eventually relate to this thing called the unit circle that we're going to learn. And yeah, we'll go over more about how this relates to the unit circle in later videos. The last thing I want to say is if you're really curious where these values came from for pi over 3 and pi over 6, you can look at these pages in your book. Okay, thank you for watching.